All right, let's just dive right into an absolutely wild space event that's unfolding right above our heads as we speak. We're currently tracking a multi-ton rocket stage that's literally hurtling through the vacuum of space on a direct collision course with the moon. It's this fascinating situation that perfectly mashes up astronomical tracking, accidental science, and some really pressing realities about space governance and technology policy.
In this explainer, we're going to cover 1. A lunar collision course, 2. Tracking the stray rocket, 3. An accidental science experiment, 4. The threat of space debris, and finally, 5. Governing the lunar frontier.
Part 1. A lunar collision course. We're starting right in the thick of the action with an object on a definitive crash trajectory.
So, picture this. Back in January 2025, a SpaceX Falcon 9 rocket launched a couple of satellites toward the moon. Totally normal, right? But after finishing its primary mission, the spent upper stage was basically abandoned in this unstable orbit. It just didn't have the fuel left to make it back to Earth or push itself out into deep space. So it became completely stranded.
Now, trapped in that erratic orbit, this massive stray piece of hardware is slated to smash into the moon. And guys, this is not going to be a gentle tap. Astronomers expect it to hit at a blistering 8,700 kilometers per hour on August 5th at exactly 12:05 p.m. Indian Standard Time.
Which brings us to part 2, tracking the stray rocket. You might be wondering, how on earth do we know exactly when and where a dead, unpowered rocket is going to strike?
Well, look at this timeline. It's basically a masterclass in space detective work. This was all spearheaded by an independent astronomer named Bill Gray. He started tracking this rocket within days of its launch in 2025. Over a whole year, he accounted for the most microscopic orbital changes. Actually, by January 2026, he established a 100% certainty of a collision. And by April, he pinpointed the exact location, giving scientists a very crucial 3.5 months to prepare for it.
Now, Gray pointed out on his website, Project Pluto, that we were actually really lucky here. Spotting an object months or even years after launch is incredibly difficult. This whole situation highlights the absolutely vital role of independent amateur astronomers in monitoring our skies, especially when official agencies might not be tracking every single piece of dead hardware up there.
Because of his meticulous tracking, we know exactly where this thing is coming down. The impact location is the Einstein crater, sitting on the western edge of the moon's near side. And what's really staggering here is the precision. Despite the vast distances, the current estimates for the impact carry an uncertainty of just about 5 seconds. Just 5 seconds.
Moving on to part 3, an accidental science experiment. This is where it gets super interesting, because we're pivoting from a massive space littering mistake into an incredible scientific opportunity. Rather than just brushing this off, experts see this collision as a really rare chance to study impact mechanics. Think about a natural meteorite strike. When a random space rock hits the moon, we have no idea what the exact size, mass, or speed of the object was. But scientists called this a controlled source event. We know exactly what the Falcon 9 upper stage is made of, how heavy it is, and how fast it's moving. It essentially turns the moon into a giant accidental laboratory.
According to a paper by planetary scientist Benjamin Fernando and his colleagues at the U.S. Los Alamos National Laboratory, this impact is going to trigger 3 distinct observable things. First, a flash of light lasting less than a second. Second, a massive cloud of debris and vaporized rocket material will get kicked up. And finally, based on computer models, it'll carve out a brand new crater roughly 20 to 30 meters across. That's huge.
And this is exactly why astronomers are geeking out. You see, moon dust is totally different from Earth dust. By watching how it hangs in the non-existent atmosphere after the crash, we can predict the kinds of harsh dust storms future human colonists might face. They also plan to monitor lunar seismic activity. Plus, depending on how the rocket tumbles right before impact, it might even carve out a rare double crater.
But hey, unfortunately, grabbing a lawn chair and your binoculars isn't going to cut it for this one. The flash won't be visible from Earth because it's happening on the moon's sunlit side. Any attempt to watch it is going to require a specialized telescope or satellite observation. Plus, if you're observing from a place like India, the moon will actually be below the horizon at noon when the impact happens anyway.
All right, part 4. The threat of space debris. While this crash is definitely a boon for science, it really pulls back the curtain on a much more alarming macro-level issue.
Because if we're just accidentally dropping multi-ton rocket stages onto the lunar surface today,
It begs a massive question about orbital responsibility. Seriously, who is actually protecting the moon from our ever-expanding footprint of space junk?
Dr. Ranjana Kaul from the International Institute of Space Law noted that this lack of debris regulation is a very serious problem. As space agencies and private companies target the moon for long-term bases, mining, and satellite networks, accidental interference is becoming a real mathematical probability. Unregulated debris doesn't just threaten future plans, it threatens the scientific achievements we've already made.
Luckily, the Einstein crater is pretty far from the equatorial and south polar regions where most landings actually happen. But hypothetically, imagine if this rocket stage happened to strike a significant historical location like the Shiv Shakti point where India's Chandrayaan-3 landed. A piece of modern scientific heritage could easily be obliterated in an instant by falling junk. Which leads us perfectly into Part 5, Governing the Lunar Frontier. This brings up the somewhat unsettling reality of our current situation. It is essentially the Wild West out there in terms of international space law. Dr. Kaul hit the nail on the head regarding the legal reality here. Because our Outer Space Treaty does not recognize sovereignty in outer space, just because a country happens to land a rover at a site, it doesn't suddenly own that piece of the moon. Therefore, there is virtually no legal instrument in place right now to protect those specific historic sites from another country's or some private company's falling debris.
And since the rules are practically non-existent, everyone's kind of doing their own thing. Bill Gray pointed out that space agencies like NASA and the European Space Agency have been pretty careful. For instance, the upper stage for the Webb telescope was put into a safe orbit away from the Earth-Moon system. China has recently started directing stages toward the Pacific Ocean or Sun orbits. SpaceX, however, has made no public statement on its disposal policy regarding the specific lunar impact. Now, efforts are being made. Over at the United Nations, the Action Team on Lunar Activity Consultation, or ATLC, is trying to build some consensus among spacefaring nations on things like landing sites, lunar dust mitigation, and debris rules. But as Dr. Kaul points out, UN decisions are made by consensus. That means getting every single participating country to agree before a proposal becomes binding international regulation, and that process can literally take years.
So here's the crucial point we're left with today, and it's a massive one for science and technology policy going forward. The moon is expanding rapidly as an active laboratory, and private companies are moving incredibly fast. If our legal frameworks are so sluggish that they can't even prevent a spent rocket from accidentally bombing the lunar surface today, how in the world will we govern the crowded, active lunar bases of tomorrow? It's a massive challenge we have to solve, and the clock is definitely ticking.